Okay, we will study about quadratic function inequality. Quadratic function inequality has two different cases. One with the y is greater than or less than equal to x squared minus 6x plus 8 with a y one side with a quadratic expression on the other side, or we have a instead of y they place as a 0, so they're comparing with a quadratic function with a 0, which part is a greater, which part is less than 0. That's two different questions you can do for quadratic. If you have a y on one side and quadratic expression on the other side with the inequality, then you have to graph quadratic function and you have to choose one side and shading. That's the solution for quadratic inequality. And if you have a 0 on the other side, then you solve it by either factoring or quadratic formula. Find the zeros. You have to find the zeros, and you will find in a number line, and you will shading the parts that satisfy inequality. So we're going to solve it. First, we have y is less than or equal to x squared minus 6x plus 8. This time, since this is given as a standard form, I will use the formula, which is a axis of symmetry formula is x equal to negative b over 2a. Use this formula to find the vertex, and we're going to graph it. So a value for here will be 1 since it's 1x squared, and b value will be negative 6, and plug it in. X equal to negative b over 2a equal to 6 over 2, which means a 3. Axis of symmetry is a 3, and then plug it in. So y value equal to 3 squared minus 6 times 3 plus 8, which makes 9 minus 18 plus 8. So negative 9 plus 8 become a negative 1. So the vertex will be 3, negative 1. I will graph axis of symmetry first, which is at x equal to 3. I'm going to make it a little bigger. And then negative 1 will be right here. And then let's plug it in. Since I know that a value is 1, that means it's open upward. And when you plug it in, 1 to the right side, which is a 4. When you plug it in 4, then you will get 4 squared minus 6 times 4 plus 8, which is a 16 minus 24 plus 8. You will get negative 8 plus 8, which is a 0. So 4, 0 here. And then reflecting points will be 2, 0. And you can plug it in 5. Another point is 5. And 5 squared minus 6 times 5 plus 8 will be 25 minus 30 plus 8. Negative 5 plus 8 will be 3. So it will be 3. So 5, 3, and then 1. Will be 1, 3 here. So you can graph it. And when you graph it, remember you have to check the inequality here. If it doesn't have an equal sign on the bottom, then it will be dashed line. If it's a greater or less, then you have to use a dashed line. And if you have a greater than or equal to or less than equal to, then you have to use a solid line. For this one, you have to use a solid line and graph it like that. And then y is less than or equal to, that means shading below the graph, so shading here will be the answer. And then you're going to do next problem here. If I rewrite, always you have to have a y on one side, so you add a 2 on both sides. So y is a less than or equal to negative x minus 3 to the square plus 2. This one is already in a vertex form, so we can find the vertex at 3, 2, and then you see a value, a equal to negative 1, which is a less than 0. We can conclude the graph should be open downward. So I will plot the points with first drawing an axis of symmetry at the x value, which is the x equal to 3. So x equal to 3 as the axis of symmetry, and 3, 2 is a vertex. And then you plug it in 4 or 2 this time, the next right next to the vertex point. So y equal to negative 2 minus 3 to the square plus 2, which is a negative with a negative 1 square, which is 1 plus 2 makes 1. So 2, 1. And then you can plot the reflecting points. And then I will plug it in 1, which means negative 1 minus 3 to the square plus 2, which is negative 2 to the square, negative 4. Negative 2 to the square will be 4, but you have a negative in front. So negative 4 plus 2 will be negative 2. So 1 with a negative 2. Then you will get another reflecting point as a 5, negative 2. And you see the inequality has an equal sign, so it will be a solid line. And then we have to shade the parts where y is a less than equal to the graph quadratic. So less than means below the graph, so it's inside here for the below parts. And then this one, this time I will change it to the vertex form by using a vertex, changing vertex form by adding c. So first, y is a greater than 2. If you have a leading coefficient other than 1, you have to factor out. So 2 with a x squared minus 2x. You have to decide to add something here. And I have a negative 6 here, but that means you have to subtract 2 leading coefficient is different, 2 times of this one, whole thing, you have to subtract here. So first we're going to decide what we have to add inside the parentheses. Half of the x term, which is a negative 2 divided by 2 to the square makes 1, right? So I will add 1 there. And then leading coefficient is a 2, so 2 times 1 become a 2, you have to subtract 2. And if I rewrite after that, y should be greater than 2 with the vertex form x minus 1 to the square minus 8. So I can find the vertex at 1 with a negative 8, and axis of symmetry will be x equal to 1. So I will graph x equal to 1 as an axis of symmetry. And then vertex as a x 1 negative 8 here. And then let's plot some points, which is a 0. So if I plug it in 0, 2 times 0 minus 1 to the square minus 8. So negative 1 to the square will be 1 times 2. 2 minus 8 will be negative 6. So it will be negative 6. So 0, negative 6 is here. Then you have a reflecting point as a 2, negative 6. And then maybe plug it in negative 1. So 2 times of negative 1 minus 1 to the square minus 8. Negative 2 to the square, which is a 4 times 2, 8. 8 minus 8 will be 0. So it will be 0 with a negative 1. Negative 1, 0 means you have another point which is a 3, 0 as a reflecting point. And you see here, I'm going to graph it with a little bright colors, so in that way you can see it's a greater, doesn't have any equal sign, so you have to use a dashed line. So the graph will be with a dashed line. And y is a greater. If it is open upward graph, if y is a greater, then you have to shade inside like that. Okay, and then we will see the graph solving quadratic inequality algebraically. First, we have to factor. So to factor this, you have to find out the number that multiply to be negative 15 and add it together to be negative 2. Find the two factors when you multiply together to be negative 15 and add it together to be negative 2. So I found 5 times 3, which you have to plug it in. You have to put one of them as a negative to be a negative when you multiply together. So negative 5 times 3. So I can rewrite as a x squared minus 5x plus 3x. I found the negative 5 and 3, and you place with the negative 5x and 3x instead of negative 2x and minus 15 and grouping together. So factor out, common factor for the first two will be x and x minus 5. And then the other two will be 3 with the x minus 5. So I can take the x minus 5 as a common factor again, and then the leftover parts will be x plus 3. And then you can say that was a less than 0. If I plot in a number line, those as an equation to be a 0, we have a x equal to 5 or x equal to negative 3. So x equal to 5 on the right side, negative 3 on the left side. And this time, if it doesn't have equal sign here, the inequality has only less than, then the parts that makes a 0 should not be included. So it will be open circle. And then look at the x squared, a value as a leading coefficient is a positive. So I can say the graph looks like maybe this way, like that. So you can say the parts where less than 0 will be these parts, which the graph is less than. So we can say the value, the inequality solution is x is a greater than negative 3 and less than 5. Or as an interval notation, negative 3 and 5. That's what I do.